Okay, our topic this time is sequence and series. Sequence is a function whose domain is the set of positive integers or the set of positive counting numbers 1, 2, 3 up to n. A sequence is a list of numbers separated by commas. Example, 1, 1, negative 1 half, 1 third, negative 1 fourth form a sequence. A series represents the sum of the terms of a sequence. A series is what you get when you add up all the terms of a sequence. For example, adding the terms above, 1 plus negative 1 half plus 1 third plus negative 1 fourth is equal to 7 over 12. The 7 over 12 is the sum of the series. Okay. Types of sequence and series. One is arithmetic sequence. It is a sequence in which each term after the first is obtained by adding a constant called the common difference to the preceding term. The formula for an arithmetic sequence is e sub n, the nth term, e sub 1 is the first term, n is the position of the term, and the common difference. For the sum of the arithmetic sequence, it is equal to n over 2 times quantity a sub 1, the first term, plus the last term. Or it can be also equal to n over 2 times quantity 2 times a sub 1 plus n minus 1 times d. Okay, another type of sequence is geometric sequence. It is a sequence in which each term after the first is obtained by multiplying the preceding term by a constant called the common ratio. The formula for the geometric sequence is e sub n, the nth term, e sub 1, the first term, and r, the common ratio. The geometric series results from adding the terms of a geometric sequence. N of the sum of n terms of a geometric series, a sub n, is equal to summation of e sub 1 times r to the k minus 1, as k starts from 1 up to n. Or if we take the terms of this series, so a sub 1, if k is 1, so 1 minus 1 is 0, so that becomes r to the 0, plus if k is 2, 2 minus 1 is 1, r to the first. If k is 3, 3 minus 1 is 2, so on and so forth, up to the nth term, n minus r to the n minus 1. Okay, another type of sequence is a harmonic sequence. It is a sequence whose reciprocals form an arithmetic sequence. A general rule for harmonic sequence, we have e sub n equals 1 over e sub 1 plus n minus 1 times d. For example, this harmonic sequence, 1, 1 half, 1 third, 1 fourth, 1 fifth, and 1 sixth. If we take the reciprocal of this sequence, reciprocal of 1 is 1, reciprocal of 1 half is 2, reciprocal of 1 third is 3, then 4, 5, and 6. This sequence form an arithmetic sequence. So we call the sequence above as harmonic sequence because its reciprocals form an arithmetic sequence. Okay, next, another type of sequence is Fibonacci sequence. It is a sequence whose next term is obtained by adding the two preceding terms. The formula for Fibonacci sequence is a sub n equals a sub n minus 1 plus a sub n minus 2 for n greater than 2. For example, this sequence, 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, 5 plus 8 is 13, so on and so forth. Okay, let us have some examples where we apply our knowledge about sequence. Find the sum of all multiples of 5 between 1 and 100. Okay? The first term between 1 and 100, which is multiple of 5, is 5. Next is 10, 15. Then the last term is 100. Okay, these terms form an arithmetic sequence with a common difference, or with the first term 5, the last term is 100. If we subtract 10 minus 5 is 5, 15 minus 10 is 5, so the common difference is 5. Okay, first is how many terms are this arithmetic sequence? So we are going to solve for n using the formula. Okay, a sub n equals a sub 1 plus n minus 1 times d. Okay, our last term is 100. Our first term is 5. N, which we do not know. Common difference is 5. Solving for n in this equation in one unknown, distribute 5. Then cancel out 5 and negative 5. Then solve for n. Divide both sides by 5 so that we get the value of n. So n is equal to 20. And the sum of this multiples of 5 is number of terms 20. There are 20 terms which are multiples of 5 over 2. The first term is 5. The last term is 100. Simplify. So the sum of the arithmetic series is 420. Next, find x so that x minus 1, 2x minus 2, and 3x plus 6 are terms of a geometric sequence. Okay, let R be the common ratio of a geometric sequence. So we're going to form ratio out of these terms. So R sub 1 equals R sub 2. The ratio are equal. Let us form ratios. So 2x over x minus 1, rather 2x minus 2 over x minus 1 is equal to 3x plus 6 over 2x minus 2. So this is R sub 1 and this is R sub 2. Let us solve for x in this equation by cross multiplying. So 2x minus 2 times 2x minus 2 equals 3x plus 6 times x minus 1. Simplify. Distribute. So 2x times 2x for x squared. 2x times negative 2. Negative 8x. Then, okay, this is the product of two binomials. Okay, this is the product. And on the other side, 3x times x is 3x squared. After simplifying the product of these two binomials, we have 3x squared plus 3x minus 6. Then solve for x. Transfer this term to the left. This becomes negative and this becomes negative also, and this negative 6 becomes positive 6 and 0 at the right side. Combine similar terms. 4x squared and negative 3x squared is x squared. Negative 8 and negative 3 is negative 11x. Positive 4 and positive 6 is positive 10. Solve this quadratic equation by factoring. So the factors are x minus 10 times x minus 1. Solving for x, equating its factor to 0, and solving for x, so x equals 10 and x equals 1. Let us check. Substitute if x equals 10. So in our original sequence, if this x is 10, so 10, this is our sequence. Substitute x with 10, so 10 minus 1, 2 times 10 minus 2, 3 times 10 plus 6, simplify, this is 9, this is 20 minus 2, this is 30 minus 6, so this is 9, this is 18, this is 36. Take note that if we divide 18 divided by 9 and 36 divided by 18, the ratio, the quotient is the same. Okay, so they form geometric sequence. However, if we substitute x equals 1 in the original sequence, it does not form a geometric sequence. So only 10 as the value of x that makes this sequence a geometric sequence. Okay, next problem. A family saves 1,000 pesos in January, 1,200 in February, 1,400 in March, and so on. How much will they save in 1 year? Okay, take note. If we enumerate the savings from January, February, and March, this 1,100, 1,200, 1,400, so on. This forms arithmetic sequence with a difference with the first term 1,000. The common difference is 200. If we subtract the term by its preceding term, the difference is 200. So there are 12 months in a year, so n is equal to 12. Let us determine the sum of the savings for 12 months. The formula, n over 2, substitute in our formula. N is 12, first term is 1,000, n is 12, common difference is 200. Okay? So first term is 1,000, n is 12, common difference is 200. Simplify. Okay? And multiply with 6. So the savings for the whole year is 25,200. Okay? So the amount of money they will save in 1 year. Next problem. A ball is tossed to a height of 4 meters, rebounds to 40% of its previous height. Find the distance the ball has traveled when it strikes the ground for the 5th time. Okay, we have here the figure of the ball that is tossed to a height of 4 meters, strikes the ground for the first time, and rebounds up to a height which is only 40% of the previous height. So 0.4 times 4, it returns to the ground, rebounds again, and it reaches a height which is 40% of the previous height, so on and so forth, up to the 5th time it strikes the ground. Okay, so the first, let us analyze the problem. The first term is, the height is 4. The next height is 0.4 of 4. And then preceding, the next height attained when it rebounds is 0.4 of the preceding one. So on and so forth. So let us examine the terms of the sequence. If we divide e sub 2 by e sub 1 or e sub 3 divided by e sub 2, we get a common ratio. Okay, a sub 2 the over a sub 1. 0.4 times 4 divided by 4 is equal to 0.4. And so with the other terms. Okay. The question is find the distance the ball has traveled when it strikes the ground for the 5th time. So the total distance in every time the ball goes up, it has two distances. So we are going to multiply the summation of the geometric series by 2 to get the total distance. So this is equal to the sum of a geometric series is equal to a sub 1 times quantity 1 minus r to the n over 1 minus r. For the first term is 4. Our common ratio is 0.4. N is 5. Okay, substitute. Sub 1 is 4. Common ratio r is 0.4. N is 5 over 1 minus 0.4. Simplify. 0.4 to the 5th is 0.01024. 1 minus. Simplify this quantity. It is equal to 0.98976. Multiply it with 4. It's equal to 3.95904. Divided by 6 is equal to 6. And multiply further. So the total distance is 13.1968 meters. This is meters. Total distance traveled with the ball is 13.1968 meters. Next problem, determine the first 5 terms of each defined sequence and give their associated series. Okay, letter A, negative 2n raised to the n. Okay, the first 5 terms, a sub 1 up to a sub 5. And its corresponding series is the sum of the terms. So what is a sub 1? A sub 1 is substitute n with 1. So 2 times 1 raised to the first power. A sub 2 is substitute n with 2. This is negative 2 times 2 raised to the 2. A sub 3 is substitute n with 3. Up to 5. Then simplify this first term. When simplified, negative 2 times 1 is negative 2 to the first, negative 2 times 2, negative 4 raised to the second, negative 2 times 3 is negative 6 to the third, so on. Negative 2 to the first is negative 2, negative 4 to the second is 16, negative 6 to the third is negative 216. Then negative 10 to the 5th is negative 100,000. Its series, the sum of the first 5 terms is negative 2 plus 16 plus negative 216 up to negative 100,000. The sum is equal to negative 96,106. For letter B, the first 5 terms, so substitute n with 1 minus 2, simplify. Okay, this is 5 times 1 is 5 minus 2, 3. This is 10 minus 2, 8. 15 minus 2 is 13. This is 25 minus 2, 23. And its the series, the sum of the terms, you add these 5 terms, the sum is 65. Okay, that's enough for this afternoon.